All right, welcome again to the TestWizardry class. This is lesson 7. Today we're going to learn about writing tests using the TestNG library. And we're also going to talk about how to use loops and collections to iterate through things. So let me first present you with a challenge. Today what we want to do is we want to admit people to Hogwarts, or rather to accept or reject people. If we look in our original TestWizardry console app, we say, if you're under 11 or older 11, you can't get into Hogwarts, right?
So the share is on.
Oh, yes, thank you. Let me try sharing again. All right. So to reiterate, right, when we are admitting people into Hogwarts, we have a simple check that says if they're younger than 11 or older than 11, they're not admitted to Hogwarts. And so you've got to be 11 years old. 11 years old is the age at which you start attending Hogwarts. So you have to be 11 to be accepted. And another implicit thing that we haven't mentioned is you have to be a wizard or a witch to be accepted into Hogwarts. So let's, rather than structure this as just this big conditional, let's create a class for Hogwarts that defines these requirements, right? So we'll start off, we'll just say Hogwarts and we want to admit someone to Hogwarts. Admit or accept, I don't know, one of those. And then you would take the person, right? I guess we want that after the player. So Hogwarts, accept player. And I guess we'll put this down a little bit below. I just need to get familiar with my code again. So now what we don't have, this will tell us, this is a great thing about an IDE, Hogwarts cannot be resolved. What do we want to do? We want to create a local variable called Hogwarts. Well, it's not an, I mean, it can start out as an object, but what it's going to be is it's going to be a school. School Hogwarts. Now, school hasn't been implemented. We want to create a school class, right? So let's create a school. And we want to create it in our main TestWizardry package, not the TestWizardry console. And so we've got a school, and well, there's a lot of things that a school can do, right? Well, there's grades, there's classes, there's graduation, but the one thing that we're concerned about right now is admittance, right? So a school admits someone, right? So our function, we're going to call it admit, and it's going to take a person. Now, I'm going to go back and say, well, actually, a school, there's multiple schools, right? There's Hogwarts, there's different schools. All these schools admit someone. So school is really an interface, right? And Hogwarts is one implementation of that interface. So we have a Boolean, and Boolean means true or false. We want to create an interface of school that, so any school should be able to admit students. And how it does that is going to be different depending on the school, right? Harvard or Stanford or Montana State University or what is it, ITI? Is that the big technical school in India? Or ITT, something like that. Anyway.
It's IIT.
IIT. There we go. All these schools have different criteria for admittance, and they look at every person's application and they decide. Well, Hogwarts is no difference. Let's, I don't know the admittance requirements for these other schools, but, oh, I guess I chose accept. Let's change it to admit here. All right, so we've got a school called Hogwarts, and it has admittance. Now it says admit magic user, but now a magic user is also a person. Our player is going to be a person. So that's something I need to consider, that our magic user is a person. We probably need to layer that down a little. Where are we? Person, create player. What is the error here? Create player. Oh, it returns a magic user instead of a person. Because we also want players to be able to be non-magic users, or at least for this demonstration. All right, so we're admitting a person. We've got a school. Next thing is Hogwarts may not have been initialized. Because school is an interface, you can't create a new school. You have to, right? You can't create a new tree. You have to create a new pine tree or a new maple tree or something like that, right? You have to be specific. So we need a specific type of school. We're going to call it Hogwarts. And this maybe isn't the best design, but it'll give us something. Now it says Hogwarts cannot be resolved. Create class Hogwarts. So we can go that. We can either use our help, or we can just do it manually. So I'm going to do it manually. New class Hogwarts. And class Hogwarts, well, it implements school. And now this is going to tell us school cannot be resolved to, oh, well, that's because it's not capitalized. Now it's going to tell us add unimplemented methods. Well, there's one method in school. Now it just has this semicolon on the end. There's no block implementing it. And this is what an interface does. It defines the interface, the contract. It defines what it does, but not how it does it. A class that implements it defines how it does it. So we're just going to implement, and my IDE here will help me out. It's going to allow me to admit people to my school. It implements it, and right now our full implementation of admit is just return false. So let's go ahead and try this out. Now we can import Hogwarts instead of just school. And our code compiles. And we can, let's see, we've got, okay. We'll just put this in here. We'll create a Boolean, call it admitted. So we're calling Hogwarts school admit, and it's just returning false. So this admitted is always going to be false right now. And so let's just print that and run. What is your name? My name is Aaron. What is your quest? No, I'm male, and I'm a wizard. How old am I? I'm 45, not 11. Yeah, I'm still 45. So it says Aaron is a 45-year-old wizard. False, meaning that I'm not admitted to Hogwarts. So let's make this a little clear, right? So if admitted, let's say, congratulations, you've been admitted to Hogwarts. Else, sorry, you were not admitted to Hogwarts. All right, so we've got some logic here. We'll go ahead and run this again. What is your name? Aaron. Are you male or female? I'm male. How old are you? I'm 12. No, I'm really 12. Sorry, you were not admitted to Hogwarts. If I run it one more time, I'm Aaron. I'm male. I'm 11. Uh-oh. I did something wrong. Sorry, you were not admitted to Hogwarts. Let's look through our debugger again and see what happened. I'm going to run this through the debugger. I've got to type my name again. Aaron, I'm male. I'm 11. We'll switch to the debug perspective. It looks like I went faster. And I come to my breakpoint, if admitted. Well, admitted is false. And I realize why. It's because I haven't written the logic to implement this yet, right? So let's rewrite this. We'll go ahead and stop here, our debugger. And what I want to do is I want to say if person.age equals 11, or rather let's do, now if we do exclamation equal sign, this means not equals. So if the person who's trying, if the person who's applying, I guess we should probably change this to apply. I like that verbiage better. Now, this is run in a few different places, right? It's in my console where it says Hogwarts admit, and in Hogwarts class, and in school it has admit. So what I want to do is I want to use this cool feature of the IDE called Refactor. So I right click on admit, I refactor and rename. I'm going to change admit to accept. So it says found potential matches. That looks like it did not. Okay, it changed it here in the interface. It changed it here on line 32 in my TestWizardry console. Oh, the reason I have an error now is that it still needs to return something. So if it's not 11, return false. And then otherwise, else, return true. Now, one thing to notice is that if this condition succeeds, it's going to return false and exit out of this method. So we actually don't need the else statement. Sometimes it's nice to leave it there for clarity. Other times it's cleaner not to. So what we're saying is if they're not 11, false, they're not accepted. Otherwise, return true. That's a start. And we can run through this again. And frankly, I'm getting tired of typing my name. But at least it says, congratulations, you've been admitted to Hogwarts. We're going through this as we edit, and we want to be more efficient, right? We're testing as we go, but we want to write an automated test. So that's what our lesson today is going to be about. We're going to write some automated tests. So the first thing we can do is we can go to source test Java, and we can create a new class so that rather than going through the TestWizardry console and typing my name, my gender, my age, etc. every time, I'll write a program that does that for me. And I'm going to make it, I'm going to call it a Hogwarts acceptance test. And I will click this public, would you like to create a method stub? Let's click that. And now it created this public static void main, which I've typed all together too many times myself as well. And I'll just clean up those empty spaces. And I wanted this to be in my TestWizardry package. So I type package TestWizardry, and good old Eclipse will say, do you want to move this to package TestWizardry? Why, yes, I do. So it creates the folder TestWizardry, and under that I have Hogwarts acceptance test. Now you can look, I have under source main Java, I have TestWizardry, and I have Hogwarts, and on TestWizardry. So I have these parallel package structures under source test Java and source main Java. On a standard Java project, it might just be called source and test, but because it's a Maven project, it has a slightly more complex folder structure, source main Java and source test Java. So let's write our test, right? Well, what we need a person, new person, and it's always good to give your person a name. So I'm going to call it, well, let's start off with Harry Potter. Harry Potter's a new person. His name is Harry Potter. He's male and he's 11. So I need to, we can see that it actually knows where person is, but it doesn't know where male is. So what we can do is we can import static. Now remember, static means one instance only, gender.star. So gender male and gender female. And it's package TestWizardry .gender.star. Okay, so now we can just type male there. So this is a good start to our test. We've got a person. It avoids all that typing. And then what I can do is I need a Hogwarts, right? Well, I need a school called Hogwarts. And it happens to be a instance of Hogwarts school because it has the Hogwarts requirements. And I better spell school right. So this here shows me a case of I can create something and I can declare its type to be a school. It could be any school, right? It could be New Harvard or whatever. But we don't have a Harvard, we just have a Hogwarts. So in this case, our school is called Hogwarts, and the implementation of that accept method is here. They need to be 11 to be accepted to Hogwarts. All right. And then I can do if Hogwarts accept Harry. Then I can print congratulations. You've been accepted. Hogwarts. And I can then put my else here. If accepted, print congratulations else. There we go. Sorry, you were not accepted to Hogwarts. All right, so we go through, we're creating a person. We're creating an instance of Hogwarts School. Maybe we actually want to do that before we create a person. It doesn't actually matter. But so if Hogwarts accepts Harry, print congratulations, otherwise don't. And what happens? Well, Harry's been accepted, right? Now, what if we create another person? What about, who's his cousin? Dudley. He's a person. And I think they're a different age, or maybe they're the same age, I don't know. But for this example, we're gonna make them the same age. Dudley Dursley. He's a male, and he's 11. Now, if Hogwarts accepts Dudley. Now, if we've written everything right, it should say, no, Dudley's not accepted. But Dudley got into Hogwarts. How could that happen? Well, let's go back. Our Hogwarts acceptance, it'll take any person. But what we want to do is we want to make another check. We want to say if person is instance of, now what this says, is this an instance of this class, or in this case, this interface? If the person is a magic user, return true. If not, return false. So maybe we'll do our positive logic here. So we'll say, if the person is 11, well, no, what we want to do, if the person is not 11, return false. If the person is not a magic user. And I just need to add these extra parentheses. This exclamation point, you remember here, not equal to. If it's not, if this expression evaluates to true, if it does not mean true. So if person is not an instance of magic user. Instance of is one of these Java keywords that says person. Well, person is a person. but person might also be a wizard, and a wizard or a witch, we can look at, extends person and implements magic user. Now the difference here, person is a class, magic user is an interface. It tells you what it can do, but it doesn't tell you how, right? Wizard has to implement brew potion and cast spell and all those things, which we haven't gotten to yet, wizard or witch. So we've got our acceptance tests. Now what we want to do is we want to check both Harry and Dudley. So let's just cut and paste some code here. If Hogwarts accepts Harry, print congratulations. And if Hogwarts, and we'll just do congratulations Harry and congratulations Dudley, so we know what we're looking at. Sorry Harry, sorry Dudley. You are not accepted. Okay, so for each person, it's going to check Harry and Dudley, and we can see what it's going to check. It's going to check if they're 11 and if they're a magic user. And we actually want to say return false here if they're not a magic user. That'd be a good case of testing the debugger, but luckily we were able to catch it beforehand. So let's run our acceptance test. Sorry, Harry, you are not accepted, and sorry, Dudley, you are not accepted. I don't know, honestly, what's going on here. Harry is a person. Oh, Harry is a person. He's not a wizard. We need to make him a wizard. And because a wizard is implicitly a male, if we click new wizard, a new wizard calls person, name, gender, male, and age. But since a wizard and a witch implies their gender in the title, we don't need to specify that. That's a little bit of information hiding that makes it a little easier to write. So now, if we run this, congratulations, Harry, you've been accepted to Hogwarts. Now, the next thing we want to test is Hermione, but I don't want to cut and paste all this again, right? If you're typing something 3 times in a row, pretty much identically, that's probably a good hint that what you want is a loop. And this is where we're going to create a list. Now, in Java, we have an array, right? We can have an array of persons, and the array has these brackets, right? And we can call them people. And then we can do new person star or brackets. Now, what this does is this will create an empty group. We can create a group of 3 like that. And we can do people sub 0 equals Harry. People sub 1 equals Dudley. And then we'll do people 2. Oops, typo there. Equals Hermione. And we'll define that in one moment. We'll create another person called Hermione. New witch. Hermione Granger. She's female. She's 11 too. Got a typo somewhere in here. I'm just not importing witch. Oh, no, we don't need to specify female for witch. That's what it is. There we go. So we've got a wizard. We can even be more specific here. We can call Dudley a muggle to be more explicit. And we can create another person. We'll call him Aaron. I'm neither a witch nor a wizard because, well, I'm not in the Harry Potter universe. So now we've got these 4 people. If I want to add another person, though, well, let's leave that out. Let's run this through the list. Now, what I want to do is I want to turn this into a loop. Now we've done for loop for int I equals 0, I less than people length. which in this case would be 3, and then I plus plus. That will loop through my list. And we can do this. Let's go ahead and do that. And we'll eliminate the duplication here. So what this is going to do is it's going to start with 0. And it's going to go up to 3. And then it's going to increment. So I equals 0. And then at the end of this loop, it's going to be I plus plus, I equals I plus 1, 1. So it's going to go 0, 1, 2, just what we want. Now, we don't want to be specific about Harry here. We want to be specific about people sub I. Now, what this says is give me the element, the person that's in this group people that is at this index. So it'll start with 0, and then it'll go to 1, and then it'll go to 2. And then it will say, well, wait a minute. We are not less than 3 when it becomes 3, and it will not execute this loop, and it will finish the loop. So we want to also not congratulate Harry. We want to congratulate people sub I dot name. So it gets the person at the index. That's why we use I. I is a substitute for index. It's also a substitute for iterator. Anyway, so we want to say congratulations to the name of this person. And what we could actually do to make this more explicit, we can say person equals people sub I. So person 0 or people 0, people 1, people 2. So now we can just say person dot name. And then we can say same thing here. We've got our pluses. And notice how I do congratulations and then a space and then a close quote. So this is one string literal here, congratulations. And then I plus, I add another string, and I get the variable name from my person. And then I do a quote and you've been accepted. Let's make this bigger so we can all see it all. And then this is another string. So I have 3 strings that I'm adding or concatenating together. We're joining these 3 strings into one string and then printing them. Same thing with sorry, person name, and you are not accepted. All right, I think this will work. Let's see what happens. There we go. Our console says, congratulations, Harry Potter, you've been accepted to Hogwarts. Sorry, Dudley Dursley, you are not accepted. Congratulations, Hermione, you've been accepted. So great, we've got a wizard, we've got a witch, we've got a muggle. Now, I also want to add myself, who's neither a witch, wizard, or muggle. I'm just an ordinary person from the ordinary, boring earth. And I'm going to add myself to the list. And I'm going to run through this. I get an error. It says exception in thread main, index 3 out of bounds for length 3. Because I have to declare it. This is a tricky, annoying thing with arrays, right? Now I can go ahead and I can change this to 4, and it's going to work because I have 4 people, and it says, sorry, Aaron, you are not accepted to Hogwarts. Great, that's good, but now every time I add another person, I'm going to have to remember to change this number here, right? So if I add 5 people, I'm going to have to do that. For instance, we can make another person. We can make a, we'll call him Albus, and he's a wizard. Albus Dumbledore. I think that's how you spell it. And I don't know, how old is he? 99, we'll say. Oh, we don't need to specify that he's a male. I might want to optionally include that specification. So now I add another person. This is getting complicated, especially if it's declaring this people array somewhere else in my code that's not easy to track. So what I want to do is I want to use a list. Now, an array is a fixed size list. When it compiles, it says, I'm going to allocate just enough memory for 5 persons or 4 persons or 3 persons or whatever the number that I specify here is. And it's kind of fixed at compile time. So if we create more during the runtime, that won't work. Let's change this to a list of person. Now, this is kind of a weird syntax, but I create a list of people. And now first thing I need to do is I need to import Java util list. This is a collection. Now, a collection is an item that is iterable, which means you can iterate or cycle over each one, for each one. The thing that makes it iterable is, I believe the method is called hasNext. Says, is there another one? So I create a list of people, and the type of list I'm going to call is an array list. Now, you can specify, in older versions of Java, you used to have to specify that it was an array list. Now we've got these brackets of person. I need new array list. And I then need to import array list, again, in the Java util package. All right. We've got some other errors below, but we're not going to worry about that right now. So we've got a list of people, and now we can just do people.add Harry. And I can do this at any point in the code anywhere. It doesn't have to be right in the same area where I declare it. I can add Dudley. And I can add Hermione. And I can add Aaron. And I can add Albus. Mr. Dumbledore, Professor Dumbledore. So I want to point out, we've got these greater than less sign, which is just, in this case, it's another type of bracket, right? We've got parentheses, which is everyone knows what parentheses are. Then we've got these square brackets, which, like I said, are used for like subscript, or, people use them for a footnote when they're typing. And then we have these curly brackets, which are used for a block, right? So parentheses are a function argument, or in this case, like 4 isn't really a function, but it looks kind of like one. Or for order of precedence, as we saw here in Hogwarts, that we want to evaluate, is person instance of magic user, and then we want to evaluate that they're not an instance of magic user, and then we want to combine them all and return true or false. All right, so we've got these 3 types, and then we've got this other one, which is, now it's used to say a type. So this is called generics in Java, and collections like list are the one that use generics the most. What it's saying is, I want a list of person object. I could do a list of strings, or a list of wizards, or any object. Now, I can't do a list of int, because int isn't an object, which is why Java has a class called integer, which is a wrapper around the primitive int object. Anyway, in this case, we want a list of people, or a list of persons, a list of the person object, and we're calling it people. The name of our list is people. And what type of list? It's an array list. An array is, like I said, a list of things. So I don't know why Java was this specific in the naming, but that's what it is. Now, in newer versions of Java, Java 8 and above, you don't have to specify the type. And it looks like it's going to say, for JRE 1.7 and above. So this is where I would need to change my project settings. Rather than do that right now, since we're short on time, I'm going to keep that array list of person. if I change it to Java 1.7, 1.8, 9, 10, 11, 12, 13, 14, or 15, then I don't need to specify that. Just like in version 14 and above, I won't need to specify. Here I can just say it's a variable, and it will say what type of variable? Well, it's an array list of people. Anyway, so I have a list of people right now, and I could iterate through this. Now, list, it doesn't have a length. Length is a property of an array. It has a size. And it doesn't have an index, or it doesn't have, it does have an index, but I would need to get. So I'm using another parentheses. So what I'm doing is I'm getting the first index of this, because I'm not referencing an array, I'm referencing an object of type list. Objects don't have that bracket array accessor for each item. It calls get, which under the covers does the same thing. Excuse me for yawning there. So now we've got a list that we can add and remove from without altering our initial. So we can actually create new people at runtime and run through this. So let's go through, see what happens. I put a 1 here instead of an I. So it was getting Dudley each time because Dudley is at index 1. Harry's index 0, Dudley's index 1, Hermione's 2, Aaron 3, and Albus 4. Because rather than 1, 2, 3, 4, 5, it goes 0, 1, 2, 3, 4. Here we go. Congratulations, Harry Potter, you've been accepted. Sorry, Dudley, you were not accepted. Congratulations, Hermione. She was accepted. Witches and wizards, they're both magic users. Aaron, I'm just a person. I'm not a wizard. I wasn't accepted. Albus Dumbledore was not accepted. Why is that? Well, he's over 11. So we have these two requirements. You have to be a magic user, a witch or a wizard, and you have to be 11 to be admitted to Hogwarts. That's all we've got so far. And now I have this test, which is great. I can run this. I can add new users. I've got a pretty good coverage of different scenarios, right? I'm testing wizards. I'm testing muggles. I'm testing witches. I'm testing people. And I'm testing wizards to make sure that it's an 11-year-old and not someone else of a different age. So I think I've got a pretty good test suite here for my Hogwarts acceptance test. But we can still improve upon this. This is where TestNG comes in. And this is where I thought I'd be at least 15 minutes ago in the class. So let's go back a step. TestNG is a testing library. There are two principal libraries in Java for testing, TestNG and JUnit. JUnit is the older one. TestNG was created by a man named Cedric Buist because JUnit had some deficiencies. Now that was JUnit version 3 when TestNG was created. Since then, JUnit is at version 5, and it's overcome many of those deficiencies, but also there's some philosophical differences. For instance, in TestNG, you can make one test running dependent on another test, and on JUnit, you cannot do that. Tests are all independent. With TestNG, you have data providers, which allow you to run a test over different data sets, which is kind of useful. Java or JUnit has something similar, but not quite the same. I think the TestNG data providers are a more elegant solution than what JUnit uses. TestNG also has the ability to run tests in parallel. Now, there is a risk here because TestNG parallelization is not necessarily thread safe. You can write unsafe code that TestNG will try to run in parallel. And if you're using that unsafe code, then TestNG will run into what are called race conditions or shared memory issues, where if two tests are running and they alter something similar, then the TestNG parallelization can cause unexpected behavior, right? If you have two people, say, signing up for Hogwarts, for attending Hogwarts or for attending TestWizardry, and they try to use the same username. Well, we have a requirement, or we will have a requirement, that each user has to have a unique name. Who wins in this case? Well, whether it's a real world scenario or a test, it's the first person, but it's not always that easy. What if the process of creating or reserving a slot is separate, and it requires user intervention, where they then submit a confirmation email or process a payment or something, whatever it is, on a different website, that you now have an issue where you have two things that are running in parallel that may conclude at different times based on external variables. And then you'll have some indeterminate or unpredictable behavior. So that's one downside to TestNG versus JUnit. And JUnit handles this in a different way, which is, say, it doesn't handle it. Rather than JUnit handling it, it passes it off to Maven, which runs tests in parallel by either spawning different JVMs or creating test runners in a thread-safe way with Maven, which is actually the recommended way, at least in my recommendation. But we're using TestNG instead of JUnit for this example, and we're not going to worry about parallelization at this time. Another thing that TestNG has that JUnit doesn't have is the ability to group tests into suites using either programmatically or an XML file. So let's take this test. And why would we want to use TestNG instead of, I mean, we have a perfectly good test. We can run this as a main class. Well, we talked about grouping tests and running tests in parallel. And then one last thing is being able to report them and run them, right? And if I want to run a bunch of different tests, like a Hogwarts acceptance test, and then the sorting hat test, which determines which house, Gryffindor, Slytherin, Ravenclaw, or Hufflepuff, that someone will be added to, then we'll need to run them separately, or we'll need to create another program that can run them together. And we'll have dozens, if not hundreds, of tests in the end. So TestNG and JUnit both provide a test runner mechanism that, rather than creating a main class and running these all separately, you can run them in groups and get reported all of your test passes or failure. So with all that wording, let's go ahead and include TestNG. In Eclipse, the first thing you need to do is you need to go to the Eclipse Marketplace. So under Help, you go to Eclipse Marketplace, and we're going to install the TestNG plugin. I believe it already includes a JUnit plugin, and we'll compare that another time. But when you get to the Eclipse Marketplace, what you want to do is you just want to search for TestNG. And you can see it's already installed for me. If you wanted to, if you don't have it installed and you want to install it, you would just click install, like on these other options that show up in the search results. So TestNG is installed, and I just wanted to demonstrate that. Once it's installed, it provides a couple things. It provides a way to run your TestNG tests inside Eclipse, and it also provides you access to the TestNG library. Now, there's some other ways we could go about this. We could actually, in our library, right? We could add a library in our project. And to do that, I would go to build path, configure build path on my project. And I would go to libraries, and I would say add library. And because I have it in the plugin, I can add TestNG. I can also add an external jar and go to my downloads, and I can add TestNG here. But because I have the plugin, I don't need to do that. What I can do is I can just create a test and add it. Now, the other way is in Maven, I can add a library in my dependencies. And actually, I'm going to use the UI. If I click on my Maven pom.xml, that's my project object model, I can go to Maven in the right-click menu and add dependency. And I can do TestNG and search for that. I can also go to Google, and I can go to Maven Central. I'll just type TestNG dependency, and it'll find the Maven repository. Now I can go here, I can download, I can click on a specific version and download the jar file right here directly, which I've done. That's why it was in my downloads directory. I can also grab this dependency XML snippet and paste it into my pom.xml. And thirdly, I can look at this. So the group is org TestNG, the artifact is TestNG. I can actually go here and go org TestNG, artifact TestNG, and it will find it theoretically. And it pasted it there. Now, it didn't paste my version, which I have in my clipboard, so I'm going to go ahead and do that. So now I've installed, or not installed, but I've specified that a dependency of my Maven project is TestNG. And the group, if you remember, my group is TestWizardry. My artifact is TestWizardry console. My version is 010 maybe, or 001, I don't remember. And the scope means that this dependency is only needed when I do a Maven test, not when I do a Maven build or a Maven package or a Maven release, or whatever other Maven target there is. So I've added my TestNG dependency. Technically, that's not needed with Eclipse. With Eclipse, I can go ahead and do that. Now, I talked about source main Java and source test Java, which is a little different. This is where it comes in. I've got my Hogwarts acceptance test. What I want to do is I want to create another one here. And I'll create a class. And I'm going to do Hogwarts acceptance test. And I'll call it TestNG. The other way I can go about this is I can actually click on my package and I can do new, other. And you can see it has an option here. It has an option for TestNG. And I can create a TestNG class. And it'll do it in source test Java. And well, we'll call it new test. Let's go ahead and start with our new test right here. So it says run all. It will actually run it. It says detected TestNG. There's nothing here though. I have a function, right? I'll just call it my test. And I can click run here. And I'm going to move my brackets down because I like them lined up. But now I can do a test, right? I can say, I can use assert true. And then I can say 1 + 1 is equal to 2. And now I need to import that assert. So I can add static import for assert true. All right. So you might notice here, it has test. Now this run debug, this is stuff that Eclipse just adds for the UI for convenience. But test is actually editable code. This is called an annotation where it has this @ sign. And what that does is TestNG looks for a method that has the annotation and says, it has the test annotation, I will run this. I'm not going to go into that now. I've got an error, connection reset, something happened. But I'm going to run this test. And it succeeds. Now you see here, I've got this little thing that showed up, results of running tests. I'm going to drag it over here to make it easier for me to see. Now it says all tests, default suite, default test, TestWizardry, my test. And I can create another one. Another test. Get my capitalization right. And this one, I'm going to assert true, or I can assert false. I can also assert equals. And there are some other things, but just for practice, I'm going to do 1 + 1 is equal to 5. This one should obviously fail. Oh, I need a semicolon there. I deleted it. And now I can run all my tests here. I can also right-click on new test and run as TestNG test. And we can see my output: test run, one test, failure 0. I have, oh, I forgot to include the annotation at test. Now I can run them all. And I should have one passing test, my test, and one failing test, another test. So in this case, okay, it just took a little longer, but it says detected TestNG. It is strongly recommended to add doc type suite at the top of your files. Otherwise, TestNG may fail or not work as expected. So in other words, I could write suite here. Anyway, I'm not going to do that right now. And then I can run my tests again. I guess I didn't need to run them again. I don't know why it's taking so long either. Normally what you do for TestNG to create a suite is you create a file called testng.xml. Oh, and I don't want this assert JUnit. I guess that was the convert to, or anyway. Let's go ahead and clear that out and run that again. This is taking altogether longer than it should. All right, so we've got 2 tests and 1 failure, none skipped. We can scroll through our console log and we can see, well, we have an assertion error, right? My test passed, another test failed. Well, it's pretty clear why. 1 + 1 does equal true, but 1 + 1 does not equal 5. And we see here the stack trace. The stack trace is, it shows all the different steps that were run, and it's essentially outputting the debug information. So we've got an assertion error, and we can see eventually it comes up to, where in my file is it? Oh, here at new test line 17, and it shows new test line 17 is this assertion failure. We can correct this, right? We can say 1 + 4 = 5, and that will succeed. So that's the main thing that's the simplest thing you can see in a test, that you create a class, you create a method, you use an assertion, and then you add this annotation test to it. And we can see they both passed now. That's good. That wasn't some very interesting tests. Let's go back and let's create our Hogwarts acceptance test as a TestNG test. So first thing I'll do is I'll create a annotation for test, public void, and I'm going to use should accept wizards. And then I can do assert true. What do I need? I need Hogwarts. I need a school called Hogwarts. And you can see our abstraction here. It's a school, but it's also a Hogwarts school. And we need a person. We need a new wizard. And we'll call him Harry. Let's say he's 11. Now we need to assert true that Hogwarts accepts Harry. And we can add the TestNG library. And next thing we need to do is import test. And finally, we need to import assert true. And so we can run that test. And it should accept wizards, and it succeeds, right? We can even add our logic here. And we can refactor this out. Boolean accepted equals Hogwarts accept person. Assert true accepted. We can do our logic here. We don't really need this, but this is the logic we'll have in our actual game. Let's actually borrow that from our other. If they're accepted, let them know. All right, so let's run our Harry test again, see how that looks. Congratulations, Harry. You've been accepted. Passed, should accept wizard. And we see over here on our left-hand side, remember this started down here, if you still have it down here, should accept wizards. I like it up here on the side, next to my Project Explorer. Now let's see, should reject that, our next test is that they should reject. Should reject muggles. Public void should accept muggles, and it is a test. Now we've only got one instance of Hogwarts, so we can actually move that out of our method, and we'll have every instance of the test share this Hogwarts. We can actually even create a static instance, but that's not quite thread safe. What we want to do is we want to have a school, and we want to create. I was going to talk about using thread local to make it thread safe, but instead I'm not going to do that. I'm going to just do this. So what I want to do is I want to create a method called setup. And then I'll do school equals new Hogwarts. And let's go ahead and borrow from our Hogwarts acceptance. And let's create our list of people. By putting Hogwarts at the class level, putting our school at the class level, instead of in the method, it'll be visible from any method in our class. And we want to do the same thing with our list of people. And we need to grab all the people that we created. Oh, and then we can just call this school, because maybe we want to try a different school. All right. So it should accept wizards. We don't need to create Harry here. We've already created him up above. Let's move all of our people out of our list as well. You'll see why. So now I can accept Harry. And so if Harry is accepted, Well, sure. We'll move this into its own function here. We'll call this acceptance. It takes a person. We want to make our tests clean. So if there's reusable code in our tests, we want to refactor those out into functions as well, or methods. Hope this is not void. It is Boolean. It returns whether we've been accepted or not. And we can just call that as a function inside our assertion because it evaluates to true or false. That's Boolean. Oh, and we need to pass in Harry. Maybe this code would actually make sense to be in the school class. Nah. We'll keep it here in the test for time's sake. And I realize we've already run over. So what we'll do is we'll move this into acceptance too. So we can do accept false, acceptance Dudley. What have I got wrong here? Oh, we just need to add assert false. Now we've got Harry, we've got Dudley. Let's go ahead and run all. There we go. Oh, we've got 2 failures. Cannot invoke school except because this school is null. Oh, we defined a school, but we're not calling our setup class. The reason we aren't calling our setup class because TestNG ignores any method, right? We could call it a test, but this isn't a test. What this is a before method is what we call it. So we say before each test method, we call this before, and we'll need to import that. And there's also a corresponding after method. We can call that whatever we want. It's traditionally called tear down. You can call it clean up or whatever. And what we want to do is maybe move that here. So if accepted, then write that out. So what we would have is well, nope, that's not going to make sense. We'll keep that out. We're going to ignore, just know that there is an after method. We can we'll just say test done in after method. We'll import that. All right. So we've got a setup before and a tear down after. Our setup creates our school, adds all our people to our list, which we're not doing yet. And then we've got 2 tests here. One test should accept wizards, should accept muzzles. Let's add another test, should accept witches. That's Hermione. And let's go ahead and run all those. So we can go back over here and do run all. That's rerun all. Rerun failed. What I actually want to do is I want to rerun all here. Oh, it just ran except wizards. Okay, I'll hit run all. So it should reject muggles. Why didn't that succeed? It accepts witches, it accepts wizards, and it should reject expected false but found true. Interesting. Should reject muggles online 53. And then we see it goes to assert line 77. What's going on? Where is my acceptance? Oh, cut and paste error. It's Harry. It's not the person, right? We're passing in a different person. These are common errors that happen all the time when you're writing code, which makes tests really useful. In this case, it was an error in the code. Now we've got all these tests passing. Now what we want to do is we want to should reject older wizards. And that would be Albus. And it should reject let's call it wizards too young. Wizards too old and too young. Now listen, we need a Jenny. Jenny Weasley is only 10. So let's go ahead and create Jenny. That was something, that's another test scenario that didn't occur to me before. Get to this. And that's the great thing. I have both this list of tests and my reported results, both in the console and in the plugin UI. It's as easy as adding a new person to create a new scenario here. Now, Jenny's not a wizard, so maybe we should be more specific. In this case, we know that wizards and witches are identical except for gender. I've got something wrong here. That's better. Oh, I didn't add a @test to these. So in order for TestNG to know that they're tests and we want to run them, we need to reject wizards too young and reject wizards too old. Run all again, and this will be the end of our class for today. All right. So I guess what I should have done is given you an assignment. The assignment now is I'm going to check in this code. What I want you to do is I was hoping we would get to using data providers, but we haven't. I want you to create a couple of sample wizards, witches, muggles, ordinary people, and write a test that tests each of those. So create a new test here in your Project Explorer, right? Actually, so we've got new test here. Create a test in new test that will test different wizards. So create a file, call it whatever you want, Hogwarts more acceptance tests. And then don't use the examples I've used. Create a test to test a wizard and create your own wizard, your favorite characters, whether it's Ron Weasley or Severus Snape, Draco Malfoy. Figure out if Hogwarts will accept them. I will commit this code for you to look at as the example, and I will also send out the assignment and the recording of the video later. Anyway, thanks for your time. Have a good day, and we'll talk to you tomorrow.